Hello, I'm Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science. This is the third part of my paper, Theory of Unit Space-Time and Displacements from Unit Space-Time, Material and Cosmic Photon Subatoms and Atoms. On page 34, section 8, Origin of 21.1 centimeter radio waves. 21.1 centimeter radio waves are very useful for observing stars and galaxies because the radio waves are not absorbed by intervening dust. Conventional physicists say that this wave is generated by a, quote, forbidden transition. The intrinsic spins of the alleged electron and proton in H1, neutral hydrogen, flip. Of course, this is nonsense from the standpoint of the reciprocal system. The reciprocal system spectroscopic equations for an H transition are given by, and please see reference 14, E sub H1 I equals 13.61256 electron volts. That's the calculated ionization energy of hydrogen. Planck's constant H is 4.14 times 10 to the minus 15 electron volt seconds. And then we have the expression for the frequency nu, E sub H1 I divided by H times the quantity 1 over n1 squared minus 1 over n1 squared minus 1 over n sub 2 squared minus 1 over n sub 2 squared. The black dot indicates that it's not calculated at this point in this paper. The reciprocal system database has a feature which enables the user to input an emitted or absorbed wavelength such that the program will search over the space of all values of n sub 1, m sub 1, n sub 2, m sub 2, usually from 1 to 99, to obtain that wavelength or frequency. The result for the 21.1 centimeter line is n sub 1 equals 62, m sub 1 equals 69, n sub 2 equals 76, and m sub 2 equals 90. And therefore the frequency is calculated to be 1.42168 times 10 to the 9th hertz, or in terms of wavelength, 21.087521 centimeters, QED. This transition is not forbidden at all. Of course, with conventional theory, the orbitals would be too large. Curiously, reference 47, page 854, refers to such atoms as, quote, Rydberg atoms, quote, highly excited hydrogen atoms or hydrogen-like atoms, principal quantum number n greater than 100. Their radii range up to approximately 5 times 10 to the minus 7th meters. This corresponds to the size of a virus. But this is not a problem for the reciprocal system because the spectra are due to changes in thermal motion of the atom itself, and of course ionization changes, if any. A neutral hydrogen atom with n sub 1 equals 62 and m sub 1 equals 69 is at a temperature of 2.636 Kelvin. A neutral H atom with n sub 2 equals 76 and m sub 2 equals 90 is at a temperature of 2.613 Kelvin from the reciprocal system database. Section F, Cosmic Background Radiation, Absolute Velocity of the Local Group. The cosmic microwave background radiation, CMBR, has been measured to be at a temperature of 2.725 Kelvin, reference 39, page 531. According to the reciprocal system, this radiation comes from the cosmic sector. Therefore, we can conclude that the CMBR contributes to the temperature of the interstellar intergalactic H1. So, a starlight coming from the cosmic sector slightly heats the H1 of our sector. By the reciprocal postulate, starlight from the material sector appearing in the cosmic sector slightly heats the CH1 of that sector, where C here means cosmic, of course. The CMBR is not a relic of the alleged Big Bang. Larson says, reference 3, page 387, because of the inversion of space and time at the unit level, the frequencies of the cosmic radiation are the inverse of those of the radiation in the material sector. Cosmic stars emit radiation mainly in the infrared rather than mainly at optical frequencies. Cosmic pulsars emit X-rays rather than radio frequency radiation, and so on. But these individual types of radiation are not recognized as such in the material sector because, as we found earlier, the atoms of matter that are aggregated in time to form cosmic stars, galaxies, etc., are widely separated in space. The radiation from all types of cosmic aggregates is received from these widely dispersed atoms as a uniform mixture of very low intensity that is isotropic in space. Given that this radiation is isotropic, we can define a local reference frame at rest relative to the CMBR. Reference 59 shows that the CMBR is slightly blue shifted in one direction and slightly red shifted in the other direction. The net result is that the local group is moving at a speed of 600 kilometers per second toward the Virgo cluster. Of course, the relativists deny that there is any, quote, preferred coordinate system, but this is a logical candidate for one. Section G, astronomical sources of radiation based on reference 3. 1. Radio waves. From matter moving at intermediate or ultra-high speeds, from early white dwarf product of type 1 supernovae, from the remnant of type 2 supernovae. 2. Infrared waves. From infrared stars down to 1000 Kelvin, failed stars down to 300 Kelvin, protostars, newly formed variable stars. Intense infrared radiation comes from matter at ultra-high speeds, such as quasars, and low intensity is from matter at normal speeds. 3. Optical. From normal stars on the main sequence, from the low-speed products of type 1 and type 2 supernovae. 4. Ultraviolet rays. From the central region of Seyfert galaxies, or any kind of, quote, active galaxy, from matter moving at intermediate or ultra-high speeds. 5. X-rays. From atomic isotopic adjustments due to explosions of stars or galaxies. Stage 4 of white dwarfs, which involves a return to the speed range below unity. From cataclysmic variables, from novae, from pulsars which fail to escape the galaxy and are coming back and reducing speed to below unity. From class M stars, X-rays leaking out because there is less thickness of overlying matter, and leakage from the sun's core which heats the corona. So incidentally, that's the source for the high temperature of the corona. Leakage of X-rays from the sun's core. 6. Gamma rays. From atomic isotopic adjustments when matter drops below unit speed, from cosmic, stellar, or galactic explosion, gamma ray bursts. Note, X-rays and gamma rays are non-thermal. That is, they come from atomic isotopic adjustments. Section H, Doppler shift equations. Reference 40, pages 193 and 194, gives the usual expressions for the Doppler shift for both low and, quote, relativistic velocities as follows, but using our equation number. Quote, when the radiation of frequency nu sub L is emitted from an object traveling at a velocity v, with respect to an observer at rest, the observed frequency nu sub obs is, and you can see the equation there, 29a, for v much less than c and theta much less than 90 degrees, the observed value of frequency is nu sub L times 1 minus v sub r over c, where theta is the angle between the velocity vector and the radiation wave vector. The radial velocity v sub r equals minus v times cosine theta is positive when the radiating object is moving away from the observer. Consequently, when receding objects are observed at optical frequencies, the lines are shifted towards the red, meaning toward longer wavelengths. The ref shift z is defined as z equals lambda observed minus lambda sub L divided by lambda sub L, or nu sub L minus nu observed divided by nu observed, and approximately v sub r over c, where lambda observed and lambda L denote respectively the wavelengths of the observed and emitted line radiation, observed and use of LGNet, respectively, the frequencies of the observed and emitted line radiation, and of course, vis a vis the radio velocity. For large velocities, this reference says, the special relativistic Doppler effect is expressed by the equations 32 and 33, and you can see the equations there. Measured velocity is often correct for the orbital motion of the Earth about the Sun and the Sun's motion with respect to the group of stars. However, the reciprocal system rejects the use of special relativity in these equations because, as equation 30 shows, the measured value is used in the definition of z. So if z is calculated to be greater than 1 by equation 30, that means that the speed is, in fact, greater than c. Larson discusses this issue in reference to page 307 as follows, quote, extension of the redshift range above 1 raised a question of interpretation. On the basis of the previous understanding of the origin of the Doppler shift, a recession redshift above 1 would indicate a relative speed greater than that of light. The general acceptance of Einstein's contention that the speed of light is an absolute limit made this interpretation unacceptable to the astronomers, and the relativity mathematics were invoked to resolve the problem. Our analysis in Volume 1, Nothing But Motion, shows that this is a misapplication of these mathematical relations. In the situations to which those relations actually do apply, there are contradictions between values obtained by direct measurement and those obtained by indirect means, such as, for instance, arriving at a speed measurement by dividing coordinate distance by clock time. In these instances, the relativity mathematics, i.e. the Lorentz equations, are applied to the indirect measurements to bring them into conformity with the direct measurements, which are accepted as correct. The Doppler shifts are direct measurements of speeds and require no correction. A redshift of 2 indicates a relative outward motion with a scalar magnitude of twice the speed of light. Note, the z-value, for example, of a quasar is a combination of the galactic recession plus any explosive velocity away from the associated galaxy. The high z-values of quasars, for example, are not due to extreme distances. Section I, Einstein-Podolsky-Rosen effect, quantum entanglement. Suppose that two photons originate at the same event and move in opposite directions. In the material sector, the motion appears to be outward in space. In the cosmic sector, the motion appears to be outward in time. In actuality, we are moving inward in space away from the photons, and the cosmic observers are moving inward in time away from the photons. We have no independent motion in coordinate time at low vectorial speeds, and since the photons do not either, we were able to effect a change in both photons by a change in one of them. Likewise, the cosmic observers have no independent motion in coordinate space at low vectorial inverse speeds, and since the photons do not either, cosmic observers are able to effect a change in both photons by means of a change in one of them. Existents which are contiguous in either space or time may both be affected by application of a suitable single force. Because photons are stationary in the natural reference system, they are not lost from either sector and are not disappearing over the time or space horizon. The universe is not, quote, running down toward a slow, quote, heat death. The second law of thermodynamics applies to kinetic energy only, not to total energy, unlike the first law. Section J, plane polarization. By definition, if a stream of photons all have their linear vibrations in the same plane perpendicular to the direction of propagation, the radiation is plane polarized. Astronomical sources of polarized radiation come from matter moving at upper range speeds, intermediate and ultra. Quoting Larson, reference 3, page 224. According to our theoretical findings, 1, all radiation from objects with upper range speeds, except that generated by indirect processes, is non-thermal, and 2, all such radiation is polarized as emitted. Where a lower polarization is observed, this is due to depolarizing effects during travel of radiation. The reason for this is, of course, that this radiation originates from a two-dimensional space-time region. White dwarfs, pulsars, quasars, active galactic cores, and jets all emit polarized radiation. Section K, elliptical polarization, rotational bases. So far we've covered uniform translational motion and linear vibrational motion. The next type of motion is rotation. A one-unit rotational displacement of a photon creates a rotational base. Two types of rotational base exist. The material rotational base, which has the rotational displacement in time, less than unit speed, and the cosmic rotational base, which has the rotational displacement in space, greater than unit speed. Penrose, reference 33, pages 546, 547, shows a diagram of circular polarization, which is actually in agreement with the picture we get from the reciprocal system. So for once, the conventional theory and the reciprocal system agree. Circular polarization results from spinning photons about the direction of motion in space-time progression. However, the spin is scalar in the reciprocal system, whereas it is vectorial in conventional theory. Therefore, helicity, direction of the spin, doesn't matter in the reciprocal system, only the speed, and so h over 2 pi is not used as the unit of angular momentum. By inspection, one can see that a photon, imagined as vertical, has three rotational axes, two horizontal, perpendicular axes through its midpoint, and one vertical axis along the linear vibration. The rotational spin can be represented in four different ways, all equivalent. The choice to use is a matter of convenience. The four ways are rotational displacement, effective rotational displacement, rotational speed, and rotational frequency. For the material and cosmic rotational bases, we have Table 2. And here you can see the columns are circular polarized light. We have the material rotational base and the cosmic rotational base. The photon frequency, that is the ground frequency, is 2r in the case for material particles and 1/2 r for cosmic particles. Rotational displacement is simply 1-0-0 for material rotational base, or parentheses 1-0-0 for the cosmic rotational base. And naturally, the effective rotational displacement is 0 for both particles. And then you can see the rotational speed and rotational frequency there, where r is the Rydberg frequency. Again, m equals material, c equals cosmic, r equals the Rydberg frequency, 3.2881 times 10 to the 15th cycles per second, or revolutions per second. Rotational space displacements are enclosed by parentheses. The photon frequencies given in the table are for the ground state. Obviously, non-ground state material photons would have higher vibrational frequencies, and non-ground state cosmic photons would have lower vibrational frequencies. The rotation of the rotational base is around the first horizontal axis of the photon, which is referred to as the principal axis, or sometimes the primary axis. The rotational base does not have a rotational displacement around the other two axes, which are termed the subordinate or secondary, and the electric. However, keep in mind that we start with unity, not zero, in the reciprocal system, so the rotational speed is not considered zero around these two other axes, when there's no displacement, as is indicated under the column rotational speed. Likewise, rotational frequency is not considered a zero around these two other axes, when there's no displacement. But the speed or frequency in the two non-displaced dimensions have no physical effects. The one displacement of rotational motion is not effective in stopping and reversing the space-time progression. The two rotational bases still move at the speed of light. Hence, they both have the designation 0-0-0 under the column effective rotational displacement. This form of the spin representation is useful for expressing combinations of particles, which we will see in the section of this paper devoted to subatoms. As the references 1 through 10 show, the sequence of additions of displacements alternate between space and time. Material particles are rotational displacements in time built on photons with space displacement. Cosmic particles are rotational displacement in space built on photons with time displacement. Section 3 subatoms. A. De Broglie diffraction and wave functions, probability functions, psi. In the reciprocal system, all subatoms and atoms are rotating photons. The spins of the atoms, which will be discussed in a later section of this paper, hide or shield or screen their photons, so that the wave aspects of photons and C atoms can usually be neglected. This is not the case with electrons, positrons, or neutrons, which do not hide or screen or shield their photon substrate. These subatoms therefore undergo diffraction in crystals. We therefore do accept de Broglie's hypothesis that these particles can act as waves. However, atoms such as alpha particles scatter. Here the scattering is a function of the rotational displacements of the alpha particles and the targets, such as gold atoms. Therefore, the reciprocal system usually works with the spin numbers of atoms and subatoms rather than with, quote, wave functions. This contrasts with quantum mechanics, in which reference 31, page 80 says, quote, a particle is described by associating with it a wave packet formed from the superposition of an infinite number of plane waves. Each plane wave moves with a phase velocity which may exceed the velocity of light. The individual phase velocities are not observable. The quantity that is observable is the velocity of the localized disturbance, or group velocity, which is equal to the velocity one normally associates with a particle less than the speed of light, italics atom. But an infinity in a physical theory is a red flag. It's a disproof of the theory. Furthermore, conventional theory says that the square of the wave function psi, quote, gives the probability of finding a particle at a given place. In order to reconcile the wave and particle pictures of matter, we must give up the idea that the location of a single material particle can be specified exactly. Instead, we can talk only of the probability of finding a particle at a particular location at a particular time, reference on page 88. This is not so in the reciprocal system. Space-time and all motions are ultimately absolute. And so, yes, we can specify the exact location of a particle at an exact time. There's no Heisenberg uncertainty principle in the reciprocal system. The de Broglie wave equation is simply lambda equals h over p, where lambda is the wavelength, h is Planck's constant, and p is the linear momentum of the particle. Reference 31, pages 82 through 87, gives many examples of the use of this equation. The reciprocal system is in full agreement here with de Broglie. Reference 33, page 499 gives, quote, the Schrödinger equation for a single particle of mass m moving in an external field whose energy contribution is V equals V as a function of x, y, and z. And you can see the Schrödinger equation, where I is the imaginary number. This equation is very difficult to apply. The textbooks and handbooks give only the most trivial solutions. For example, see reference 47, pages 835 to 841. The quantum mechanics literature is full of approximate solutions, but these are still worthless for practical application by engineers, and besides, they all disagree with one another. Larson, reference 6, page 8, quotes de Broglie as saying, what seemed to me to be eminently desirable was a return to precise space-time representations which could give a clear picture of what they were supposed to portray. In other words, de Broglie himself did not accept Schrödinger's wave equation, and neither do we. Penrose, reference 33, page 528, discusses the puzzling feature of the, quote, collapse of the wave function, wherein a jump is made to a state reduction whenever a measurement is deemed to take place. The reciprocal system has no such issue. the spin numbers in the reciprocal system versus that in quantum mechanics and the standard model. The three spin numbers in the reciprocal system represent displacements or speeds around three perpendicular axes of one photon for subatoms or two photons for atoms. The one spin number of quantum mechanics represents an angular momentum, units of h over 2 pi, about an ill-defined axis of what? One needs to specify a subnuclear theory to explain what is rotating in quantum mechanics. Now, let's go through a side note on the standard model of particle physics. According to the so-called standard model of particle physics, the, quote, fermions are matter constituents and have a spin equals 1/2, 3/2, 5/2, etc. There are two types of fermions, leptons, which are electrons and neutrinos, and quarks, and there are 18 types of those. The, quote, gauge bosons are force carriers and have spin 0, 1, 2, etc. These include the photon, the W particle, the Z particle, the Higgs boson, the graviton, and the gluon, of which there are 8 types, which allegedly holds the quarks together. Isn't it curious that the standard model needs two bosons to explain mass and gravitation? The fermionic hadrons include the proton and antiproton, and the neutron, etc. The bosonic hadrons include the pion, the kaon, etc., which are supposedly comprised of quarks and antiquarks. See references 33, 34, 35, 36, 40, and 49 for the details. The so-called quarks, which are supposedly contained within many of the subatomic particles and mesons, do not have a fixed mass. See reference 34, page 389 for a table of quark masses. For instance, the supposed D quark has a mass which ranges from 3 to 7 MeV. But this is nonsense. It would mean that particles built up from quarks do not have a fixed mass, which they certainly do have. They are also said to be point particles and have a speed close to that of light. A complete table of subatoms and mesons is given in reference 40, pages 1182 to 1202. Quarks need the following quantum numbers. It's amazing. You need to specify quarks, you need to have Q, I, spin, N, S, C, B, T, and Y. As an example of the complexity of representing the properties of a particle in the so-called standard model, consider the proton P. This supposedly has three quarks, U, U, D. The U quark has these properties: Q equals 2/3, I equals 1/2, I3 equals 1/2, spin equals 1/2, N equals 1/2, S equals 0, C equals 0, B equals 0, T equals 0, Y equals 1/3. The mass of the U quark is 1.5 to 3 MeV. The D quark has these properties: Q equals minus 1/3, I equals 1/2, I3 equals minus 1/2, spin equals 1/2, N equals 1/3, S equals 0, C equals 0, B equals 0, T equals 0, Y equals 1/3. The mass of the D quark is said to be between 3 and 7 MeV. The spin of the proton itself is supposedly 1/2, and its J value is 1/2. The mass of the proton is 928.27 MeV, but the masses of the internal quarks don't sum to this at all. Besides, the quark particles are just points. How can they combine to make a particle with extent? In contrast, the reciprocal system represents the spins of material and cosmic protons as follows. And here you can see table 3, material proton, proton, cosmic proton, where 2r over pi is the natural mean of rotation frequency. Note that these are for chargeless particles. For the normally charged M proton, we add a plus sign to the spin representation either before or after, like 2-1-1 plus. For the normally charged C proton, it would be parentheses 2, parentheses 1-1 minus. In working out the details of the rotational spin about each of the three axes of the photon of a subatom, eccentricity must be minimized. So, for instance, we don't have a particle with displacements 2-0-0. The complete table for subatomic particles follows by inspection, together with their identifications. Note, intermediate particle like the compound neutron in H1 is one that has two rotational systems, one of which is massless. And
this is reporting from Transpower Corporation.
Okay, please study this table carefully. Table for subatomic and intermediate particles. That completes part 3 of my paper.